Hello friends, welcome to Engineering Debunked. Today we're going to start linear algebra, and in this specific video we're going to look upon vectors, vector operation, and what is the span of two vectors. Now let us start by understanding what is a vector. Suppose we have a coordinate system. This is an xy plane, this is the x-axis, and this is the vertical y-axis. And in this plane, if we have suppose we have an arrow in the xy plane. In most of the cases, the arrow is rooted on the origin of the xy plane, that is 0 comma 0, and there is a tip of the arrow. And the tip of the arrow is basically showing the direction of how to reach from the tail of the arrow to the tip of the arrow. For example, this vector shows us how to reach from 0 comma 0 to 8 comma 4, which is you move 8 units towards the x-axis and 4 units in the y-axis to reach the tip of the arrow, which is defined by column matrix where 8 and 4 denote the x and y coordinate of the specified vector. Now, moving forward, we'll look upon vector addition. What is vector addition? Suppose we have two vectors, the orange one denoted by 8 and 4, and the green one denoted by 6 and minus 2. Now, what if we want to add these two vectors? What will we do is we will shift one vector, the tail of one vector, to the tip of the another vector, somewhat like this. And now we'll try to connect the tail of the orange vector and the tip of the green vector. So it will give us the new resultant vector, and we can find out the coordinates of that resultant vector by adding the coordinates of the two individual vectors, somewhat like this: 8, 8, 4, 6 minus 2. If we add, we'll get the x coordinate and then the y coordinate. Now let's look at scalar multiplication. Taking the same vector 8 and 4, if we multiply it with the scalar, for example 0.5, we'll get 0.5 into 8 and 0.5 into 4. This means individually both the x coordinate and y coordinate will get multiplied by 0.5 each. So we'll get a new compressed vector which will set at 4, 2. Now, what if we multiply a negative scalar? So for example minus 0.5. So in this case also each and every coordinate, that is x coordinate and y coordinate, will get multiplied by 0.5 each, and will get compressed and reversed, and we'll get a new vector which sets on minus 4 and minus 2. Keeping this scalar multiplication idea in mind, let's move forward to the span of vectors. For covering span, let us look into a topic of basis vector. Now in the xy plane we have two basis vector, that is I cap and j cap. Now I cap is the unit vector pointing in xward direction, and j cap is the unit vector pointing in y direction. Imagine any vector in this xy plane, we can represent it in the form of a I cap and b j cap, where a and b are scalars, any scalars, and we can use a and b as scalars to represent any random vector in this plane. Suppose we have this vector which can be denoted as 6 I cap plus minus 8 j cap, 6 and 8 being the scalars multiplied with the basis vector. So you get the idea of how to denote a vector with I cap and j cap. Now, what if we take any two random vectors, that is u and v? Can we represent any vector with the combination of these two vectors? Think about it. If your answer is yes, then it is absolutely right. We can represent any random vector in this xy plane with using these two random vectors u and v. So this idea of representing any vector in the xy plane using these u and v vectors is called the span of these two vectors. If we can span the whole xy plane with these two vectors, then the span of u and v is xy plane. Now, what if the two vectors coincide on each other, somewhat like this? If u and v are on each other, now imagine any two scalars and multiply u and v with them. You will never get a point, for example here on 4 comma 2. You will never reach that. You multiply any scalar with u and v, you will always reside on this gray dotted line. So the span of these two vectors is only this line. So there is a name for such vectors. They are known as linearly dependent vectors. This is because if you multiply any scalar with u, you can get v. If you multiply any scalar with v, you can get u. But if you look at the previous example that we took of these two u and v vectors, if you multiply any scalar with u, you can never get v and vice versa. So they are linearly independent vectors. I hope what we discussed today is clear. In case you have any doubts regarding the following topic, you can feel free to leave your doubts in the comment section, and thank you.